Welcome back to this video lecture series on data structure and algorithms. Today our lesson is Dequeue concept in the queue data structure. So let's start. So what is Dequeue? Well, Dequeue stands for double-ended queue, which is again a queue data structure, but the unique characteristics of this is that insertion and deletion operation can be operated from both of these ends of the queue. This means we can do the insertion and deletion at both front and rear end. As you can see in this diagram, insert and delete, these both functions can be operated from both the sides, front and rear. Now there are mainly two types of Dequeue we can find. One is this input restricted Dequeue, where insertion is done only from one end but deletion occurs from both the ends. So in this diagram we have decided to operate the insertion operation from the front end, but delete can be done from both the ends. And for output restricted Dequeue, we can operate this deletion operation from only one end, but insertion can be done from both the ends, as you can see in this diagram. So let's move on. So the main operations that we will be operating on this Dequeue data structure is, first is the insert front operation or function, in which we will be inserting from front, insert rear, that is insertion from rear. Delete front and delete rear stands for deletion from front and rear respectively. With this help of get rear function, we can get the value at the rear position, and with the get front function we can get the value at the front. Is empty and is full is used to check for the overflow and underflow conditions. And before going on to the implementation part, let us know a few of the applications of Dequeue. So as a Dequeue supports both in stack and queue operations, it can be used as both. And the data structure supports both clockwise and anti-clockwise rotations, which can be used in certain cases using constant time, that is a big O of 1. And this rotations will be very important when we will be operating the insertion and deletion operations. So let's jump on to the implementation part in our IDE and let's see how we can do it. So I have opened my IDE and this is the main function. I have already written down the the flow of the program. Like I had told you that we will be using these functions. So what I will first do is I will first insert two elements at the rear position, then I'll get the rear value, then again I will delete a rear value, then again I will get the rear position. And from the front I will insert it from one time, then get the front value, then I'll delete it and then again check if it can operate properly or not. So in this insert operations I'll be giving this arguments. So let's say I will be inserting 3 and 4 from the rear side first, and lastly the insertion from front I will be entering 1. So before operating these functions, what I need to do is I need to initiate it. So I will here write a function initiate. Now again here we first have to define a maximum size of the queue or the circular array, because here we will be doing the implementation part using circular array only. So let's name it max and let's give it a value of 10. And here I will define this, or rather declare these front and rear variables, and also the array we will be using. So let's name it queue and the size of it will be max. So let's first define these initiate function, to which we will be initiating the queue or the circular array, or which will be implemented as the Dequeue. So the return type will be void and no arguments. So here we'll simply do this job, that I will give the front a value of -1 and rear will be given a value of 0. Now I'll first actually define this insert rear function. So let me just copy it. Here it is, and copy. And again this function also have a return type of void. The argument here is an integer type of value. So here what we'll do, we'll first check for the overflow conditions. So if I'll be using this function called is full, okay, and okay, so this bracket will be here. So before moving forward with this insert rear function, I'll be defining this is full function actually. So this will have a return type of int. You can use boolean also. So here what I'll check is return, actually I'll check if the front is at 0 and the rear has a value of max -1, or the condition is that front is equal to rear plus 1, then we'll say that yes, this is a full circular array, like this is the overflow condition. So we will here return 1, and in the else condition we will simply return 0. So here is the thing. So is full function is defined here. Now if the array is the full, then we will just print this message that overflow and new line, and for this just return. Now if this is not the case, what we'll do, so one thing we have to keep in mind, when we are inserting from rear, the thing is that adding an element will result in incrementing the index of the rear, and when we will delete a value from the rear end, we will be decrementing the index value of the rear. So it's like a clockwise rotation for addition at rear and anti-clockwise rotation when we delete from rear. And for front we will do the exact opposite thing, that is when we will insert, we will do an anti-clockwise rotation, so the index of the front will get decremented by 1, and when we will delete from front, it will be a clockwise rotation, so the index of front will be incremented. Now as we code, you will be understanding all these things. So first, the condition that is to be checked, that if rear is like max -1, so then what we'll do, we'll set the value of the rear as 0. Now else if, here we will check for the condition when the insertion will be done for the very first time. So front is equal to -1, that is the case, then we'll assign the value of the front to 0 as well as the rear to 0. And lastly, if these are not the conditions, we'll simply do what, we will actually increment the value of the rear, because we are doing a clockwise rotation along the circular array when we are inserting from rear. Lastly, we will assign the value at the rear index, so q of rear is equal to k. So that is done for the insert rear function. Now the insert front function will be same as like this, but in an opposite way. So let me just copy it, and again I'll be defining the insert front function here. So rear gets replaced with front. Here we will check if the front is 0. So we must remember that insertion from front is like anti-clockwise rotation. If this is the case, then we will assign a value of max -1. This condition will be same, and lastly this will be front minus. Okay, here this will be front, so front. Okay, and again the last change, the index will be front, where we will be assigning the value because it's insert front. So this function insert rear and insert front is done. Now what we will do, we will actually define this delete rear function. So let me copy it again. Here for delete rear also the return type is void, no arguments to be given. So again for deletion, the very simple task, we will first check for the underflow condition. So is empty will be the function we will be using here for checking the underflow condition. So before moving forward with this delete rear, let me again define this is empty. So this is also will have an integer return type, and here we'll check that if front is equal to -1 and rear is equal to 0, then what we'll do is return 1. That is, this is the condition for underflow. Else we will simply return 0 actually. So return 0. So is empty is defined. Now we will move forward. So if the underflow condition is satisfied, we'll print this message that the Dequeue is empty and a new line, and again just like return. Now if again this is not the case, so what to do? So here first we will check that if front is equal to rear. So this condition means that there is only one element left in the Dequeue. What we'll do, we'll have to store the front element. So I'll just take a variable here, let's say int I. So if this is the case, I'll first store the element that is to be dequeued from the queue. So it will be like queue of front, and I'll assign these values to 0, and rear will also be having a value of 0. Now else, in the else part we'll again check for two conditions. So firstly if, so here we have to remind that condition again, that as the insertion from the rear is being done in a clockwise direction, the deletion will be done in an anti-clockwise direction. So if rear has this value of 0, then we'll first store the data. So I will be queue of rear, and rear value will be given a value of max -1. Okay, here this will not be front, this will be rear, because again we are deleting from the rear end. And otherwise, if this is not the case, we'll simply do one thing, that is, as we were incrementing the rear index when we were inserting, we'll simply do the opposite thing. So we will actually decrement it, so like that. But before decrementing, we'll again have to store the value. So I equal to queue of rear. So that is the thing. And in this else part, we'll have to just print this messages, printf the deleted value is %d, and this will be I. So again, if this is the delete from rear and the delete from front will be almost same, but in a different way, like the things will be done in an opposite way. So the very first thing that we'll do is empty will be there just like it is. In the else part, this condition here only the change will be the front, because this is the deletion from front. Okay, and again obviously we have to change the name of the function, so delete front. In the else part, so again when we were inserting from the front end, what we were doing, it was like an anti-clock direction. Now this time will be a clockwise direction. So we have to check if the front is having the value of max -1, then we'll first store the value. So again this will be front, and here front will be given a value of 0, and otherwise again this value will be stored, the value at the front index, and this will be front plus plus because this is the clockwise direction, and this line will be same. So lastly, we just have to define these two functions, get rear and get front. So let me define it. The return type will be void get rear. Now here, whenever it's like just the top function of stack or like that, or the front and rear function, so we'll actually have to check for the underflow condition. Like if the dequeue is empty, so there is no meaning of knowing what is the value at the rear because it's actually empty. So this will be the code, and if this is not the case, that it is not an empty dequeue, what we'll have to do is that again I'll be taking this variable called I, and we'll store this queue of rear, and I'll print down a message printf that the rear value is %d, a new line, and this will be I. So I'll be again copying it because the get front function will also be the same. So let me just copy it down here. I'll have to change the names here. So get front, and here the underflow condition checking will be not a problem. So this has to be done as front, and the message will be a bit different. So the front value is like this. So I guess this is all done. We have first initiated the dequeue and set the value of the front and rear. Then we did the insertions at the rear end 2 times. Then we are asking the dequeue to get the rear value. Then we are deleting a value from the rear end. Then again getting the rear value. And after doing that, we'll be inserting a value from the front end, get the front value, then delete it. So the from the front end there will be no element, and I'll get the front. So let's now run the code and see how it works. So here is the output. So first, after we did an insertion 3 and 4, so the rear value will be 4. Then we did operate the delete rear function. So the deleted value is 4 and the rear value will be 3. Now here one thing we must observe, when we are inserting 2 values at the rear side, finally the rear index will be 1. Then after this deleted value is 4, rear index will be 0. So this 3 is at 0th index. Now let's come to the front end. When first time we will be inserting from the front, as front was 0, so this 1 will be inserted at the position max minus 1 index. So let's say max is 10, so this will be at the 9th index. This is the only value that has been inserted from the front end. Then we had deleted it. Now when a value from the last position of the circular array is deleted, front gets incremented, or that condition when front is max minus 1 will update the value of the front to 0. So now after this deletion, front is also at 0. So we can see the front value is 3 because in this case front and rear happens to have the same index. So this program has been done successfully. So this was the concept of dequeue or double-ended queue in this queue data structure. Thank you for watching this video and staying with us. See you next time.